Oke, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Ini
warahmatullahi
Waalaikumsalam warahmatullahi wabarakatuh.
okay, so we are from the group 2. So me and also Agustin Rahmi would like to answer the questions that given by the group 1 previously. So for the first questions is from Haikal, and these questions will be answers by Ami. So I will give to Ami.
Okay, thank you for our moderator. So the first question from Haikal: how did the accumulation of methane gas contribute to the mechanical failure of the dam site, and what does this suggest about the monitoring needs of landfill gas in the tropical waste sites? Okay, next slide, please. So the answer from the first question from Haikal. So contribution to mechanical failure. So at Louis Gajah, poor waste compaction and lack of gas venting allowed methane to accumulate, forming pressurized pockets within the waste mass. Methane can reduce shear strength in the waste body by increasing pore pressure and loosening the matrix, weakening the structural integrity, and the combination of intense rainfall and trapped methane likely led to the slope failure, triggering a massive waste slide and explosion like a release of gas. Next, please. And the implications for monitoring in tropical sites. So continuous gas monitoring, especially methane and CO2, is essential in tropical climates where decomposition is rapid. Landfills need gas collection systems, which is like vertical wells or horizontal trenches, to safely capture and either flare or utilize methane. Monitoring should be coupled with early warning systems for pressure buildup and slope instability. Regulatory frameworks must mandate gas management plans tailored to the tropical climate, high rainfall, and organic waste content. Back to moderator.
Okay, so for Haikal, do you have any feedback?
I no have that. Thank you.
Okay, so please proceed, Ami.
Okay, please the slide for question 2. So the second, if you were tasked with designing a new waste management system for Bandung post 2005, what key lessons from this disaster would guide your decisions, especially regarding landfill design, site selection, and also community safety? Okay, please. Okay, so for the answers, for the landfill design, we can implement engineered landfills with proper liners, leachate collection, and also gas extraction systems. And for the site selection, we must avoid steep terrain or flood-prone areas, and we select geologically stable and also low-risk zones. And then for the community safety and engagement, we establish setback distances to protect settlements from waste and gas explosions. And for the diversion and decentralization, promote waste reduction, composting, and also we can recycling at the source to reduce a landfill burden. And for institutional oversight, we can strengthen municipal capacity for planning, enforcement, and monitoring of landfill operations. Back to moderator.
All right, so for the second question of Haikal, did you have any feedback to the answers or not?
I think no follow-up question. Thank you, Areta.
Okay, thank you, Haikal. So for the questions from Sifa also will be answers by Ami. So for Ami, time's yours.
Okay, thank you, moderator. So the questions next from Shifa. The first one, how did the interplay between unregulated waste deposition, methane saturation, and hydrogeological instability create a cascading failure at Louis Gajah? and what systemic monitoring mechanisms could have prevented this disaster? So the answer. Okay, so the first one, the Lewi Gajah dam site collapse was the result of a compound disaster triggered by three interrelated factors. The first one, unregulated waste deposition, which is waste was dumped chaotically without engineering controls, which is the slope grading, compaction, or layering. And then the methane saturation, so the tropical heat and high moisture accelerated anaerobic decomposition, leading to methane gas buildup. And for the hydrogeological instability, prolonged heavy rain led to water infiltration, increasing pore pressure and also reducing shear strength of the waste mass. Okay, next please. And to prevent similar failures, a multi-layered early warning and regulatory system should be institutionalized. So the first, landfill gas monitoring, we must install methane sensors, which is in well or maybe in surface flux chambers to detect dangerous gas accumulation. And then for the slope and structural monitoring, we can employ geotechnical sensors like anclonometers or piezometers to measure slope movement and pore pressure. And then for the regulatory and institutional oversight, we can require landfills to submit real-time monitoring data to environmental agencies. Back to moderator.
All right. So for Sifa, did you satisfied with the answers of the your first question?
Yeah, that's clear enough. Thank you.
Okay, Ami, you can proceed for the answers of the second question.
All right. So for the question number 2 from Shifa, given the post-disaster shift toward planned sanitary landfills, which is Lego Nangka, and contested incineration projects, how can Bandung reconcile rapid waste management needs with long-term environmental justice for marginalized communities dependent on dam sites? Okay, so the answer for this question. Okay, so the first one is engineered sanitary landfills, which is in Lago Nangka, aiming for environmental safety. And for the waste to energy incinerators, can propose to reduce the volume quickly, but often met with the public resistance. And then this project risk excluding or harming marginalized communities, especially informal waste pickers who depend on open dams for survival. Okay, next for the pathways to reconciliation. So for the inclusive planning, participatory decision making with affected communities, especially scavenger cooperatives, which is formalizing roles of waste pickers. And then for the just transition for informal workers, we can overtraining, a cooperation formation, and microfinancing to help waste pickers transition into the formal recycling roles, then materials recovery facility or MRF workers, and also the composting operators. Okay, next. For equitable technology use, if the incineration is used, prioritize small scale, decentralized pyrolysis or RDF or refuse derived fuel over large mass burn plants. And for distributed low impact alternatives, we can invest in community based composting, biogas digesters, and local recycling hubs to reduce pressure on large disposal sites. And for the transparency and accountability, we can make waste management contracts and environmental data publicly accessible. That's all from me. Back to moderator.
All right. So for Sifa, did you have any follow-up questions or it's enough for you?
Thank you, Ami, for the comprehensive answer. That's already enough. Thank you.
Okay. Okay. So for questions from Udalfi, I will answer it directly. So for the first questions, why weren't proper safety measures like covering the waste and stabilizing the slopes put in place, even though experts had already warned about the risk? And was this more about poor planning or a bigger issue with how waste is managed in Bandung? So for these questions, the answers is proper safety measures were not implemented because of systemic poor waste management practices in Bandung, not just poor site level planning. The volume of waste sharply increased in the years before the disaster, but no structural improvements like slope stabilization or gas venting were made. And although warnings existed, like fast minor slides and methane gas measurements, local authorities ignored official recommendations. And this reflects a broader failure in waste governance, and including a lack of sustainable alternatives for waste disposal and livelihoods for scavengers rather than just isolated planning errors. So that's all for the first question. So I will ask to Delphi. Is it clear enough?
Yes, it is. Thank you.
Okay, so for next, the second questions from Delphi, could something have been done earlier, like better gas venting to prevent the explosion and landslide, especially knowing the area often gets heavy rain? So for these questions, the answer is yes. Early interventions such as gas venting systems and ensuring adequate daily cell cover could have reduced methane buildup and the risk of explosion. And methane concentrations were already detected at concerning levels in 2000, 5 years before the disaster, and this indicating the proactive gas management was possible but neglected. Moreover, slope stabilization and properly shade drainage were crucial, especially given the site's exposure to heavy rainfall. The lack of these measures made the landfill highly vulnerable, and suggesting that the disaster was preventable with proper waste monitoring and had an adherence to landfill design standards. So yes, that's all for the second questions. Did you have any follow-up questions or any comments?
Nope. Excellent. Thank you.
Thank you so much. So yeah, that is the end of our presentation. So we apologize if there's any mistakes from our answers. So thank you so much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.